All right, so here's the Bellworks surface area. Oh, and I forgot to turn this on. All these little things. All right, so let's do, according to our formula, surface area. And what it is going to be is the lateral area, all of the sides, plus my one base, right? And the formula says it's going to be 1/2 times the perimeter times the slant height plus the area of my base. So 1/2 times the perimeter. The perimeter is the distance all the way around the bottom. Oh, it's not working.
So,
Yeah.
so it'll be like 4 and then 4, because I just set my line.
Awaiting connection. Shoot, it's not working yet. Hang on a minute. Having technical difficulties. Thank you for telling me. I would have gone and done the whole problem. Let me check back here. I'm pretty sure I hit annotate back here. Annotates up. Start. Ah, there we go. I don't know what happened there. All right. So surface area is the lateral area, put it away, plus the base. So surface area is, for the lateral area, 1/2 times the perimeter times the slant height, plus capital B, that's the area of the base. So 1/2 times perimeter, that's adding all the sides on the bottom together. So that's 4 plus 4 plus 4 plus 4 times slant height is going to be this. That's my slant height, which is 6. Plus the area of my base. Jesus, you with us? Where did I get 6? That's my slant height. Is it a 5? Oh gosh. Okay, it's a 5. I better put my glasses on. Oh, okay. I saw the green line and it looked like it was taking over. 5, there we go. Thank you. Plus the area of my base. What is the shape of this base? It is a square. So the area of a square is side squared. So that's going to be 4 to the second power. Whew. And I'm warm too. All right, so let's start to put this together. That's equal to, I'm going to keep the 1/2 for a minute. And you could do this on the calculator all right now, but you have to be very careful entering it in on the calculator. 4 plus 4 plus 4 plus 4 is like 4 times 4, which is 16, times 5, plus 4 squared is 16. I like to do more of this without the calculator. I'm guessing most of you like to do it with the calculator more. I say 1/2 of 16 is 8. 8 times 5 plus 16 is 40 plus 16, which is 56 meters squared. Because we're talking about surface area, which is area still. Okay. But I want you to take a look for any pyramid, it's going to be 1/2 times the perimeter. You have to find and add up all of these distances around times the slant height. We talked yesterday about why it has to be a slant height, because if not, then those triangles would be going straight up and not coming to a point. And then plus whatever your base is. Your base could be a square, could be a rectangle, could be a triangle. Any questions on that first problem? Okay, so what figure is our second problem here? What is this? Cone. And you have to know, if we give you a picture or an image, what it is. Okay? And, oh, I have volume of a cone. I don't even, yeah. So we haven't done volume yet. But if you look on your cheat sheet, surface area of a cone, you tell me, what does it say? Look at your formula sheet. What is the surface area for a cone?
Pi RL plus pi r squared.
Pi RL plus pi r squared. What is the pi r squared?
The circle at the top.
The circle at the top, right? But if we're talking about an ice cream cone, do we have a circle at the top? No. So we're going to take this out, okay? We're not using this time because it's actually an ice cream cone, all right? Now, I know what you're thinking. You're like, well, yeah, but this part here, it's a waffle cone and that's not really there. Well, we're not going to count for that. But we can say and see there is no top to that cone. So we just need to take pi times r times L. And what I was saying before is that this is your perpendicular height. So that is 6. We need to find slant height, which is this in green. Okay? So this 2 inches, what part of the circle is that? What part of the cone is that? What do we call that? Diameter. So if I split this in half, this much of it on this right side is going to be 1 inch. Okay? So we're going to have to use Pythagorean theorem to figure out what this length is in green. So a squared plus b squared equals c squared. Here's my right angle. Here are my 2 legs. So I've got a is 1 squared plus b is 6 squared equals c squared. That's the line in green. So 1 squared is 1 plus 6 squared is 36 equals c squared. 1 plus 36, always work down, is 37. Take the square root. Take the square root. C is equal to, I need somebody to take the square root of 37. It's probably going to be 6 point something. Six point what? 6.08. We're going to round it to 6.1. So now that is my slant height. So I'm going to say surface area is pi times my radius. What's my radius? 1. Pi times 1 times my slant height of 6.1. So putting that all together, looks like 19.16. And if I round that, it's going to be 19.2 inches squared. That is your surface area. Yes? I'm sorry? The one, okay. So this 2 inches is the length all the way across that cone. That is my diameter. And the radius is half of that. Okay? So that means my radius from here to here is 1 inch. And so that's my radius here. And it was also one of the lengths of my legs. Okay? Good question if you're not sure. All right. Any questions, any other questions on those two? This one was a harder one, the second one. First one's not too bad. Okay, let's go in your notes, please, to page. Oh, I didn't write it down. I think it is the bottom of page 18. It's got a softball, baseball on the top part of it. Page 18. Oops. All right, packet. Resume. All right, so we are talking today and starting today talking about cross sections and solids of revolution. This is not the easiest thing to understand because it's very visual. Yes.
It's actually the top of 19.
Oh, okay. All right. So, thank you. Top of 19. It says a cross section. A cross section is the intersection of a solid figure and a plane. And we're not talking about an airplane. We're talking about like a giant piece of paper that extends out in all directions forever. Okay? The shape of the cross section formed by the intersection of a plane and a figure depends on the angle of the plane. All right, so we have here what looks to be a pyramid, okay? And we have a piece of paper that is slicing that pyramid horizontally, okay? And so we're trying to figure out what is the shape going to be of that cross section on the inside, okay? That's what we're trying to figure out. So, there's that one. If you look at the second figure, this is my plane right here. Should have done that in a different color. And the slice that it is making through the pyramid is kind of right here. All right. Over here, here's our plane, our what is like a giant piece of paper. And it is slicing through this three-dimensional shape. Okay, so the cross sections are going to look a little bit different. The cross section here for this first one, what do you think that's going to be? Does anybody know? Anybody got a guesstimate?
I'm sorry, what was the question?
So if I look at the cross section, right here, this slice of the pyramid, what shape do you think that's going to be?
The cutout or the part that's like?
The cutout. The cutout of the pyramid that's straight across. don't think so. I think the, what do they call it? The cross section is probably going to be a rectangle. Okay, I believe it's going to be a rectangle. All right, Jason, come on, head up. This one, I am not really sure. That one's a really tricky one because it's at a slant. And so it's kind of hard to tell. But look down here at the bottom. It says, when a plane, meaning that giant piece of paper that extends out in all directions, intersects the face of a solid, one edge of the cross section is formed. When visualizing the shape, this is the important part. You can determine the number of sides by looking at the number of faces that it intersects. So here, this plane intersects with 1, 2, 3, 4. So it has 4 sides. That's why I think it's, well, that one definitely is a rectangle. This cutout here intersects 1, 2, 3, I think 4 sides too. I'm not sure. It might be a rectangle also. Okay. But when I have a plane and it slices down the very top of this pyramid down through the vertex, it is slicing through this side, the opposite side, and the bottom. So what shape is this going to be? If I slice down the pyramid from the top, that cross section is going to be a triangle. Okay? Cross section is going to be a triangle. All right. Then looking at the bottom, it says a three-dimensional figure has plane symmetry. I want you to put a big box around that plane symmetry. If the figure can be mapped onto itself by a reflection in a plane. Okay, let's see if we can get some visuals. Grab one of these. So this is like my plane, but it would extend out forever. All right. So if you can take a prism or a pyramid or something, and when you put that plane there, depending upon where you put it, if you see the exact same thing on the other side, then we say it has plane symmetry. Okay? So I can put this plane here. I can put this plane here, all right, going through here. It's going to extend out this way. It's going to go up this way, all right, and I can put it this way. Question, let me ask you, and those of you that are listening, I'm showing a visual here. If I put my plane here, if I put my plane right here on this diagonal, everybody take a look. If you look at this side to your right, I guess, everybody take a look up here. Genesis. Take a look. If I look at this side, is this side exactly match it?
Yes.
Huh?
Yes.
Does it?
Well,
It doesn't. Because if it did, it would have a corner out here. You see what I'm saying? It's turned, but it doesn't have plane symmetry.